Hello and welcome to your daily dose of Mr. Fabs. So we are going to continue on with our PowerPoint notes. We are going to start on 42 because we have talked about tsunamis. We've talked about different types of waves, different types of destructive waves. So today we are going to get into garbage. Okay, we're going to get into all the garbage in the oceans and the garbage patches. And then we're going to shift over and talk a little bit about tides and how the moon has a pull on those tides. High tide, low tide, and how the tide actually changes depending on where you are from the equator. And then I'm also going to have some videos and a little problem set for you guys to work on, and I will post that in another video. So today we're going to move through garbage, go into tides, and get all the way up to the goodness. The tidal bore. So let's see what we can do, and let's start this off. All right, guys, garbage. So as you know, garbage is consistently littered to the ocean every single day. And the majority of this garbage is plastic, and it's actually got a weird name for it. They're called nurdles. Nurdles are these little plastic beads, these little resin beads. They're the raw product for everything that we make out of plastic. All of these nurdles go down, they're heated up, they're pressed into a mold, and then you get your plastic options, your plastic like your pens, your sunglasses. All of these are pressed into molds. So that is the main form of pollution. We're talking about our plastic water bottles. So an estimated 5 million to 20 million tons of tsunami debris is floating across the Pacific Ocean in general. My goodness, this phone is going crazy. Let's turn it off. So it's roughly 1,000 meters long. It's traveling at 10 miles per day. Think about this. This giant mass of trash is moving at about 10 miles per day. That's really quick, but it's being driven by those surface currents due to wind, right? So it's constantly just moving across. It's expected to pass the Midway Atoll in the winter of 2011 to 2012, and in fact, it did, okay? Hawaii in the spring of 2013, and it did, and it will reach the northern US coast by early 2014, and it did. We're actually seeing trash on the western coast of the United States, Seattle, Oregon, California, that came all the way from Japan. It is traveling over from Japan across the Pacific Ocean and ending up on our shores. This is real. I'm telling you this, okay? The trash is moving in the ocean. So there we go. Now, this is a little over-exaggerated as to what a trash heap may look like, but you kind of get the idea. It's an accumulation of essentially trash that has been drawn together, and it travels as one floating mass. Again, over-exaggeration. This does occur. This is a real picture. However, it doesn't look like this out in the ocean. The majority of your trash in the ocean is small, close to being microscopic, but extremely, extremely small. A lot of times the only way you can get it is by setting a drift net with small little grids in it so that a lot of stuff doesn't seep through, and then you get it that way. And the majority of it is plastic. Here you see a lot of plastic as well, but so this is a little bit closer as to what we see with regard to a floating trash mass. You see, it's just kind of like this small particulate matter, all right? And it just kind of moves with the surface currents. You could see how the wind here, if you watch my cursor, you could see how that wind has kind of pushed these currents down, and it's moving as one large mass. So trash in the ocean, it's constantly moving with the surface currents. It's moving from Japan over to the United States. And guess what? It's also moving from the United States back over to Japan. It occurs in the Pacific Ocean. It occurs in the Atlantic, the Indian, all of the oceans, all of the major oceans. All right. So hopefully that answers your questions about trash, even if you didn't have any and you didn't even know you had any. So let's continue moving on with tides. So how many tides are there in general? You're right. There's a high tide and a low tide. Now there's something, whoa, that was weird. There's something also known as a slack tide. And what a slack tide is, it's kind of like that in between. Okay, you got high tide, you got the slack tide where there's no movement, and then you got low tide, then it reverses again, it goes back up to high, and so on and so on. So what are these tides caused by? Well, they are caused by the moon, and it's the gravitational pull of the moon. Now, I bet you thought the Earth was the only thing that had gravity acting upon it. It's not true, right? We're all moving around these orbits because the sun has gravity. Okay, we're drawn to the sun's gravity, just like the moon is drawn to our gravity. However, the moon itself is large enough to have its own gravitational pull. So the water, because it's fluid on the Earth's surface, does indeed move towards the moon because the moon is pulling that water towards it. And on the other sides, it moves, it kind of like it sucks down and it moves away from the moon. All right, I can show you guys a picture in just a little bit. I'll bring you up to the big board. Actually, maybe I'll draw it right on here. Never tried that before. You guys can be my first class to see if that even works. Let me actually bring it up. And I'm gonna see if I can do it right on here. Well, we're gonna get back to that in just a second. So, looking at this, the resulting gravitational pull from both the moon and the sun draw that water. The moon has more of an effect because it is closer to us, even though the sun is twice the size. Continuing to move on, water gets pulled towards the moon. It is not uniform around the world because of the land, so the water actually has to move around the land, and for these reasons, it sometimes gets trapped in certain areas, so the tide may not go out as far, or it may not rise as far as some of the other areas. So we have a diurnal, a semi-diurnal, and a mixed tide. So if we're looking at a diurnal tide, you have one high and one low tide of equal size each day, and that's a normal tide. You get high tide, it starts to recede down to a low tide, and that's it. Okay. A semi-diurnal is you get two high and two low of equal size each day. That's what we experience every 6 hours. We have a high tide, so it goes high, 6 hours to low, another 6 hours to high, another 6 hours to low. And in those 4 6-hour breaks, you get your 24-hour daily time. Then you can have something called a mixed tide. You get two high and two low of unequal sizes each day. And you will see that usually that's when our moon is very close, or you get a spring tide, something that's very, very high, or something that's very, very low. It's kind of, it changes, it fluctuates. So they're not of equal size. So you have those 3 different types of tides. Now, continuing on, we see that where these 3 different types of tides occurs, these diurnal, the semi-diurnal, and the mixed tide. And you look down there, you can see the mixed tide, and there's no rhyme or reason. The mixed tide is everywhere there is blue, okay? So along the western coast of the United States, maybe the southern coast of the Indo-Asia continent. The semi-diurnal tides is what we have, right over here. We have those up in northern Canada as well, but we have those type of tides right here. Here is Florida. There's also diurnal tides farther out that extend, and the mixed tides. I think we covered all these. So you can see the diurnal tides are definitely the lowest amount. They show up the least. The majority of them are semi-diurnal, with mixed being in second place. So, flood and current, okay? This is the Bay of Fundy in Newfoundland, Connecticut, Canada. It occurs where water flows into a bay while high tide is coming up. And I'm gonna link a video at the end of this video that I want you guys to go watch. It shows the tide movement of the Bay of Fundy. It's amazing. We're talking like 40 feet of water. You could see it. So this guy was actually kayaking. This kayaker is kayaking through this little tunnel right here. Now that tunnel is this tunnel right here, and you could see people are walking there. Okay, all the water has completely moved out. So the water there fluctuates over 40 feet twice a day. Okay, now this is concentrating on a slack tide. I talked about this a little bit earlier. A slack tide is in the middle of high and low tide, and it's where the current actually stops moving. When you get high tide coming in, you have current pushing the water in. When you get low tide moving out, you have current moving the water out. A slack tide in this case is where there is no current. It takes a break. It's right in the middle. You could see these are more pictures from the Bay of Fundy. Here it is. Here's the United States, Maine. Here is New Brunswick and Nova Scotia, Canada. You could see people kayaking through during high tide and low tide. It's all the way down. Here is a boat. You have to be very careful because if you take your boat out at high tide, you can't come back in at low tide. So you need to come back in during high tide. So what is a slack tide? It occurs during the midpoint between high and low tides. There's little water movement due to the transition of the outgoing and incoming tides. We kind of say there's like no current. Now, this side and one more, guys. That's it. Then you get a tidal bore. What a tidal bore is, it's a wave formed during a flood current that pushes up a river. I will show you, I will link a video to this as well. It occurs regularly on the Amazon River, the in South America, the river in China, and the Severn River in England, Severn River. Some surfers take long rides on these tidal bores. You can see it's just a rolling wave that moves right up a river. And you can see it, this is a tidal bore. Here's another tidal bore. Again, they're just roving waves. So I'm gonna make a note to insert these videos in. We're gonna do a tidal bore and the Bay of Fundy. So guys, I hope you've enjoyed this. Please take your notes, and I will make sure to link these videos in at the end of the slide. I'm sure they'll be popping up here, everywhere. It might actually work if I were to put me, so they're gonna pop up here every which way. So enjoy your day, have a great day, and I will see you guys in another video. Mr. F.